An overview of inequations. Look at this inequation. If x squared is greater than x, can we deduce that x is greater than 1? The answer is no, because imagine for values such as x equals -2, x squared would be greater than x, but x is not greater than 1. So what mistake are we committing here? The mistake is to cancel x without considering the possibility that x may be negative. The correct approach is to take all the variables on one side and write this inequation as this way and then go about solving it. The solution is that x is greater than 1 or x is less than 0. We will be learning how to solve such factorization-based inequations in the next chapter. The key takeaway from this slide is that when inequations are involved, don't cancel the variables. That's not a correct operation. The correct approach is to take all the variables on one side and then go about solving the inequation. Difference between equations and inequations. Quite simply, equations involve the equal to sign, whereas inequations involve one of the inequality signs, which are greater than or equal to, and less than or equal to. A key concept here: in inequations, do not cancel the variables on the right-hand side and the left-hand side. For example, if this is the inequation, it does not mean that you can cancel x on each side and come up with this deduction. The correct approach would be to get all the variables on one side and then go about solving the inequation. Cross multiplication is not a valid operation on inequations. For example, this is the given inequation. Cross multiplying and coming up with this deduction is not correct. The right approach would once again be to take all the variables on one side and then go about solving the inequation. Addition and subtraction are valid operations on inequations. For example, look at this inequation. The correct approach is to take all the variables on one side and then go about solving the inequation. Similarly, one more example, a similar approach, moving all the variables on one side and then solving the inequation is a valid operation and the correct approach. Inequations based on factorization. Look at this problem here. The correct answer is no. Could you get that? And in less than 30 seconds? If not, don't worry, we will revisit this problem in a bit. To get the underlying concept, let's take a very basic example. The correct approach for solving such inequations is to factorize and then equate each factor to 0 to get different nodes. Let me explain what I mean here. This is the given inequation. This can be expressed this way. This is the factorized format. Now, the next step is to equate each term to 0. The terms here are x and x minus 1. X equals 0 gives us a node, and x minus 1 equals 0 gives us another node. Therefore, the nodes here are at 0 and 1. Now it gets very interesting. Imagine a number line, and on the number line, please plot these nodes. 0 and 1 are the nodes, so we plot these nodes on the number line. Now, in the rightmost side, imagine in this expression, the value of x is greater than 1, therefore something positive, and the value of x minus 1 is also positive. Product of two positive terms will always lead to something positive. Now, between 0 and 1, the value of x remains positive, but the value of x minus 1 becomes negative. Therefore, the product becomes negative. And below 0 in this range, the value of x is negative and the value of x minus 1 is also negative. Therefore, overall value of this expression is positive when x is greater than 1. It is positive also when x is less than 0, but the value is negative when x is between 0 and 1. The question seeks positive values, therefore the ranges to be considered are this range and this range. The correct answer here is x is greater than 1 or x is less than 0. A shortcut here is that simply plot all the nodes, and on the rightmost side, the value is always going to be positive, and then alternately, it will become negative and positive. The question seeks positive values, therefore, these are the ranges. For a quick summary of the approach, let's take another simple example. Here is the summary. You may want to pause the video and go through it once. If this is the expression given, the first step is to factorize, then equate each term to 0 to get the nodes. Next, plot these nodes on the number line. The nodes are 2 and 9. Now, region on the rightmost side is always positive. So this part is positive, and then the previous regions are alternately negative and positive. So we get a minus sign here, a plus sign here. Now the question seeks negative values. Therefore, the required region is this region. The required answer is that x must be between 2 and 9. For a deeper understanding of the concept, let's take an elaborate example now. Here are the first few steps. This is the expression given. We must factorize it. The first part factorizes into the first two terms here, whereas the second part factorizes into the last two terms here. Then equating each of the four terms to 0 gives us these four nodes. Next, we must plot these four nodes on the number line, -6, -5, +2, +3. Now the rightmost region is always positive, and then alternately negative, positive signs. All regions have been plotted. The question seeks positive values of the polynomial. Therefore, the required regions are these. This is what the correct answer would look like. This expression is too complicated to come on the test, but if you can solve this expression, you can of course solve the easier ones. Let us now take the question from the first slide. I had promised that you would be able to solve this question in less than 30 seconds, and yes, it should not take us any longer. Here is the number line. X minus 1 gives us a node at x equals 1, and x plus 2 gives us a node at x equals -2. The rightmost side is always positive, and then alternate negative and positive signs. We need negative values here. Therefore, this is the possible range of values of x. The values are between -2 and +1. Now the question is whether x can be 2. And we know that x is between -2 and +1. So the answer is no, x cannot be 2. Please pause the video and solve this problem. Here is the number line. The nodes are going to be at 2, -3, and 0. Then the rightmost area is positive, and the previous ones are alternately negative and positive. The question seeks positive values, therefore, the required ranges are these two. The first two answer choices can be eliminated, but the last three answer choices are very similar. The only difference is that in some places we have this equal to bit, and in some cases we do not. See, because we have this equal to sign here, ideally we should have an equal to sign everywhere, but we have x in the denominator, and denominator cannot be equal to 0. Since the denominator becomes equal to 0 when x is equal to 0, we cannot say that x is less than or equal to 0. Answer choice C should be eliminated. Answer choice D is incorrect for not having the equal to sign where they are needed. Answer choice E does not have equal to sign with 0, but it maintains the equal to sign where they are needed. E is the correct answer choice. This is among the most difficult questions you can get on the test. If you could get this right and through the correct reasoning, good job. If not, don't worry, just grasp the concepts. Please pause the video and solve this problem. The expression factorizes into x minus 2 times x minus 6 greater than 0. Nodes on the number line turn out to be at 2 and 6. values of the expression become positive, negative, and positive in these areas. It's mentioned that the value of this expression is positive. Therefore, x must be less than 2 or greater than 6. In this area, quantity B is greater, whereas in the other area, quantity A is greater. We have been able to get contradictory answers. Therefore, D is the correct answer choice. Please pause the video and solve this problem. We don't know the sign here. Let's get all the variables on one side. So we have minus 4x plus 2, and we don't know the sign here, 0. This simplifies into this expression. Now, if you see closely, on the left-hand side, we have x minus 2 whole squared plus 2. Now imagine x minus 2 squared is going to be positive. So this part is positive and plus 2 is anyway positive. Therefore, the sum of these terms is definitely going to be positive. Quantity A is greater. A is the correct answer choice. Please pause the video and solve this problem. Let's start solving from the rightmost side. The first condition given is that x is less than 54. Now let's look at the second part here. This suggests that x is greater than 1. So we got the second condition here. Now let's look at the third condition. This suggests that x is less than 17. So we got a third condition here. This gets the first condition redundant because if x is less than 17, it is of course less than 54. Now let's look at this last condition here. To factorize, we must break minus 5x into minus 15x and plus 10x, and then it factorizes into x minus 15 times x plus 10. And since this value is positive on the number line, we get the nodes at minus 10, positive 15, and these are the values. Now please notice that x has to be less than 17 but greater than 1. Therefore, x lies in this region. So x is between x 15 and 17, and it's given that x is an integer. The only integer in this range is 16. That's the correct answer. This is one of the most difficult questions you can get on the test. If you could solve this, great job. If not, don't worry, just grasp the concepts. Inequations based on modulus. Please look at this problem. There are only two possible values of mod x by x. The values are 1 or minus 1. 1 is for when x is greater than 0, and negative 1 is for when x is less than 0. Since it is mentioned that this expression is less than 1, it means that we are looking at this case here. Therefore, this value is minus 1 and x is negative. Is x greater than 1? The answer is no. Modulus of a number gives the absolute value of the number. For example, mod of minus 2 is 2. Mod of 2 is also 2. Therefore, if mod of x is 2, x may be 2 or minus 2. Very interesting questions are possible on the concept of modulus. However, GRE does not test very difficult questions on this concept because GRE is not a very mathy test. It is rather a test of logic. So we will stay within the range of concepts that appear on the GRE and explore. The first variation involves the greater than cases. These are cases in which the modulus is greater than something. In all such greater than cases, the correct approach is to open the modulus and remember to take the positive case as well as the negative case. Therefore, in this example here, when we open the modulus, one case is that x minus 2 itself is greater than 3. However, equally important is the case where x minus 2 is less than minus 3. Very important, and if you're not paying attention, you may miss this second case. Therefore, there are two cases. This is the first case where x minus 2 itself is greater than 3, suggesting x is greater than 5. And the second case is when x minus 2 is less than minus 3, suggesting that x may also be less than minus 1. Therefore, the required ranges are these two. Both these ranges satisfy the given inequation. The other variation is the less than cases. In these cases, the modulus bit is less than something. In these less than cases, the concept is that when we open the mod, the term lies between two values. Therefore, for this expression, when we open the modulus, the term lies between positive 10 and negative 10. Therefore, this is the expression that we get. You see, the term is between the original value and its negative value. On simplifying, the expression becomes this. Therefore, the required range is here. This is the range of values of x for which this inequality is satisfied. Please pause the video and solve this problem. This is the greater than case. Therefore, when we open this modulus, we will get two cases. The first case is that 2 minus x itself is greater than 10, and the other case is that 2 minus x is less than minus 10. Let's solve these cases. Now, to remove this negative sign, we need to multiply both sides by minus 1. Please remember, when you multiply an inequality with minus 1, the inequality reverses. For example, we know 3 is greater than 2. If we multiply both sides by minus 1, we have minus 3 here and minus 2 here, and you can see that the inequality reverses. Therefore, this greater than sign here becomes less than when both the sides are multiplied by minus 1. Similarly, now when we multiply both sides by minus 1, in both these cases, the inequality would reverse. In the first case, the greater than sign would become the less than sign, and in the second case, the less than sign would become the greater than sign. Therefore, the two possible ranges of the values of x are x being less than minus 8 or x being greater than 12. In the first case, quantity b turns out to be bigger, whereas in the second case, quantity a turns out to be bigger. Therefore, we have been able to get contradictory answers, and the correct answer therefore is choice D. Please pause the video and solve this problem. We have a less than sign here. Therefore, when we open the modulus, the term between the modulus would lie between 20 and its negative, which is minus 20. This expression simplifies to this expression, and once again, to remove this minus sign, we need to multiply the complete inequality by minus 1, and this is what we get. X is greater than minus 10 and less than 30. Quantity b is minus 11, and you see any value in this range is greater than minus 11. Therefore, we can conclude that quantity a is greater. Please pause the video and solve this problem. Mod x is less than 1, which means that x is between negative 1 and positive 1, which means that x is between minus 1 and positive 1. It is interesting to note that in this range of minus 1 to positive 1, higher powers of x lead to a lower magnitude. For example, if x is 0.5, x square would have a lower magnitude, x cube would have an even lower magnitude, and so on. Therefore, a case such as the first one is never possible in this range because the signs don't matter because of the modulus signs involved, and magnitude-wise, x cube is never going to be greater than x. Therefore, the first answer choice cannot be true. Similarly, the magnitude of x square is greater than the magnitude of x cube. Therefore, for cases when x is negative, x squared would be something positive, x cube would be negative, but the magnitude of x squared would be greater, as explained here. That is why the sum will always be greater than 0, and for cases when x is greater than 0, both x squared as well as x cube would be positive, and therefore the sum would be positive. So even the third case cannot be true. This must be selected. The second case is possible for all the negative values of x. For example, when x is equal to negative 0.1, you will see that this part is negative, the second part is also negative, and therefore the sum is negative. Therefore, the second choice must be eliminated. A and C are the correct answers. Please pause the video and solve this problem. An interesting property of inequations is that when the border values are put in the inequation, the left-hand side and the right-hand side become equal. Therefore, the correct answer choice must be such that when we put minus 15 in place of x, or when we put 35 in place of x, the left-hand side and the right-hand side must become equal. We can see that when we put 35 in place of x, the two sides do not become equal in these three choices. Therefore, these three answer choices can be very comfortably eliminated. In the first two answer choices, the two sides become equal when x is replaced by minus 15 and when it is replaced by 35. However, we can see that the desired interval is one range. Therefore, the desired inequation must be of the less than form. Such an inequation, when opened, takes this form, which simplifies into exactly the same range that this interval represents. Whereas the first inequation would have opened into two separate ranges, leading to not just one interval but two intervals on the number line. Besides, an easy and very intuitive way of eliminating answer choice A is to simply put a value of x in this inequation from this range. For example, x equals 0 very much lies in this range, but when we put x equals 0 in this range, we get 10 greater than 25, which is not correct. When we do the same in answer choice B, we get 10 is less than 25, which is correct. So either way, B is the correct answer choice. Please pause the video and solve this problem. This inequality is possible only when x and y have opposite signs. Imagine if x and y were both positive, this inequation would not hold, and if x and y were both negative, this inequation would again not hold. This inequation holds only when one of x and y is positive, whereas the other is negative. This is when the individual magnitudes become greater than the combined magnitude. In such cases, you will see that the sum of x and y would be a smaller quantity because one term is positive, the other is negative. When they are added, the magnitude decreases. Whereas when they are subtracted, the magnitudes will add up. Imagine something positive minus something negative will lead to a big positive number. Similarly, a negative number minus a positive number will lead to a big negative number whose modulus would lead to a greater value. You can understand this by taking a couple of examples. In one example, we can take x as positive and y as negative. In the other example, we can take x as negative and y as positive. And you will see that in both these cases, quantity A will turn out to be greater. Therefore, for all values satisfying the original inequation, quantity A will always be greater than quantity B. Therefore, A is going to be the correct answer choice. Inequations based on signs. Please look at this problem. Y squared is bound to be positive, and if x times y squared is positive, it means that x is positive. Now, if the product xy is negative, while we anyway know that x is positive, it means that y is negative. The question is whether y is greater than 0. The answer is no. Positive multiplied by positive is positive. Negative times negative is positive. Positive times negative is negative, whereas positive to the power even is positive. Positive to the power odd is positive. Negative to the power even is positive, whereas negative to the power odd is negative. Very simple, basic concepts, but very interesting problems can be raised around these. Please pause the video and solve this problem. 3x minus y is positive, but 3x minus 2y becomes negative. We can write this second inequation as this. Now we know that this much is positive because this part is same as the first inequation here. Therefore, from something positive, when y is subtracted, the result becomes negative. That means y must be positive. Now, if y is positive and 3x minus y is also positive, it means that 3x is positive and therefore x is also positive. So now we know that x is positive, y is also positive. Therefore, the product xy must be positive and therefore xy is greater than 0. Quantity A is greater. Please pause the video and solve this problem. Q squared is bound to be positive, and if P times Q squared is negative, it means P is negative. Now, the product PQ is positive while we know that P is negative. Therefore, we can say that Q is also negative. So we know that P is negative, Q is also negative, but we don't know which of these is more negative. Therefore, the relationship cannot be established. Please pause the video and solve this problem. It's a can be correct question. Therefore, we simply need to come up with one example for each of these to deduce that the answer choice is correct. The first expression can hold for a small negative value of x. Imagine, in such a case, the value of x would be the smallest, the value of x squared would be the greatest because it would be something positive, and the value of x cube would lie in the middle because it would be negative but a small negative number. Therefore, the first answer choice should be selected. The third expression can hold for a large negative value of x. Imagine, in such a case, the value of x cube would be a large negative number, the value of x squared would be a relatively small positive number, whereas the value of x to the power 4 would be a large positive number. Therefore, the third answer choice should also be selected. The fourth expression can also hold for a large negative value of x, for example, x equals minus 2 once again. In such a case, x cube is a large negative number, x is a relatively smaller negative number, x squared is positive, and x to the power 4 is a bigger positive number. Therefore, answer choice D should also be selected. However, answer choice B does not hold for any value of x. Imagine for a small negative value of x, these three will hold, but x raised to power 4 will not be greater than x raised to power 2. For a big negative value of x, these three will hold, but x cube would not be greater than x. For bigger positive values, such as x equals 2, this part of the inequation will not hold. And for small positive values of x, such as x equals 0.5, this part as well as this part of the inequation will not work. Therefore, answer choice B should be eliminated. A, C, and D are the correct answer choices. Inequations based on -1 to 1. Please look at this problem. When we think of x as positive, the values that come to our mind are generally sizable integer values such as 2, 5, etc. For such values, yes, x square is greater than x. However, for small positive values such as say 0.1, 0.5, etc., you will see that x would be greater than x squared and the answer would be therefore no. We got yes as well as no. Therefore, the correct answer is that the relationship cannot be established. And the moral of the story is that expressions behave a lot differently in this range of -1 to 1. Some interesting observations on how algebraic expressions behave in the -1 to 1 range. To begin with, look at 1 by x. For a sizable positive value of x, for example, x is equal to 2, 1 by x would be less than x. However, for a small positive value of x, such as x equals 0.5, you will see that the expression works very differently and 1 by x becomes greater than x. So you see how the expressions behave differently in this -1 to 1 range. Similarly, for a sizable negative value of x, such as x equals -2, 1 by x is greater than x, but for a small fractional negative value of x, such as x equals -0.5, you will see that now 1 by x becomes less than x. Now let's look at x squared. For significant positive values such as x equals 2, you will see that x squared is greater than x. However, for small fractional values such as x equals 0.5, you will see that x squared turns less than x. Let's look at x cubed. For significant positive values such as x equals 2, you will see that x cubed is greater than x. However, for a small fractional value such as x equals 0.5, you will see that x cubed is less than x. Similarly, for a sizable negative value such as x equals -2, you will see that x cubed is less than x. However, when x is in the -1 to 0 range, x cubed becomes greater than x. Lastly, let's look at square root x. For a sizable positive value such as x equals 2, square root x is less than x. However, when x is in the 0 to 1 range, for example, when x is equal to 0.5, you will see that square root x is greater than x. Overall, the key point of the slide is that algebraic expressions behave very differently in the -1 to 1 range from what they behave in case of bigger positive or bigger negative numbers. Very interesting problems can be raised around the behavior of algebraic expressions in the -1 to 1 range, and you must be generally cautious of this range while attempting the inequations questions. For example, while plugging values in inequations questions, you must beware of the -1 to 1 range. We will be doing a separate video on plugging values in inequations. The key point I want to make right now is that if you are plugging values while solving inequations questions, you must look at 4 ranges. Consider a sizable positive number such as 2, a sizable negative number such as -2, but also consider a small positive fraction in the 0 to 1 range and a small negative fraction in the 0 to -1 range. Only then you would have covered all the possible behaviors of the expressions in question. Please pause the video and solve this problem. It's given that x squared is less than x. We know that x squared is positive, therefore x must be positive. So choices C and D should be eliminated. Then generally x squared is greater than x for sizable positive numbers such as say x equals 2, 3, 4 onwards. Therefore answer choice A cannot be correct. Besides, x less than 1 would also include negative values, and we know that x must be positive here, so answer choice B should be eliminated. We can comfortably reach answer choice E by elimination and also by our general understanding that generally x squared is greater than x. It is only in this 0 to 1 range that the value of x squared becomes less than x, because if x is a small fraction such as 0.5, squaring it leads to an even smaller value than the original value. So the answer has to be answer choice E. Besides, if x squared is less than x, we can always factorize it and plot the nodes on the number line, the nodes being 0 and 1. We know the rightmost value is positive and then alternately negative, positive. For negative values, this has to be the range. Therefore, x must be between 0 and 1. So there are so many ways to reach the correct answer choice E here. This was straightforward, difficulty level easy. Now let's raise the difficulty. Please pause the video and solve this question. It's a can be true question. Therefore, we simply need one example for each of these expressions to select the expressions. The first expression can hold for a small positive value of x, such as x equals 0.2. value of x squared would be 0.04, x is 0.2, and 1 plus x becomes 1.2. So this answer choice should be selected. The second expression will hold for a sizable negative value of x, such as x equals -2. For such a value, 2x becomes -4, 1 plus x becomes -1, and x squared becomes 4. Therefore, this answer choice should be selected. An interesting observation here, it's not that this expression will hold for all the negative values of x. For example, x equals -0.5. You will see that for such a value, this part of the inequation will not hold. So remember, always be very careful about this -1 to 1 range. The third expression can hold for a small positive value of x, such as x equals 0.1. You will notice that for such a value of x, 2x is 0.2, 1 plus x is 1.1, whereas 1 by x is 10. Therefore, even the third expression should be selected. Correct answer is A, B, and C. Difficulty level medium. Let us now raise the difficulty further. Please pause the video and solve this question. This is an always true question. Therefore, our approach is going to be to get one example where a given expression does not hold in order to eliminate that answer choice. When we are not able to get even one such example, we will have to deduce that such an expression is always true. The first expression will not hold for a sizable negative value of x, for example, x equals -5. In such a case, you see that 1 by x becomes -0.2, which is greater than -5. So the first condition is met here. However, the second condition is not met because -5 is not greater than -5 squared, which is 25. Therefore, this answer choice can be eliminated. The second expression will not hold for a small fractional value of x, such as x equals -0.1. You will see that yes, -0.1 is greater than 1 by x, which turns out to be -10. So yes, the first condition is met here, but 2x becomes -0.2, which is not greater than x, which is -0.1. Therefore, the second answer choice should also be eliminated. The third statement will not hold for similar values that we chose for the second answer choice. For a value of x such as -0.1, you will have -0.1 is greater than -0.2. So the first condition is met. However, the second condition suggests 1 by x becomes -10, which is not greater than x, which is -0.1. Therefore, even the third answer choice should be eliminated. The fourth answer choice can be easily eliminated for all the negative values of x, big or small. For all these values, you will find that the first condition is met. For x equals -0.5, x squared is positive 0.25, which is greater than -0.5. But the second condition would not be met because x cubed becomes negative again, which can never be greater than x squared, which is something positive. Therefore, the fourth answer choice should also be eliminated. Let's look at the fifth answer choice. X is greater than 1 by x under two circumstances. The first circumstance is when x is a sizable positive number, such as, say, 2, and the second circumstance is when x is a small negative number, such as, say, -0.2. However, in both these cases, you will find that x square is greater than 1 by x. Therefore, the fifth answer choice cannot be eliminated. We can deduce that the fifth answer choice is always true. E is the correct answer. This was one of the most difficult questions you can ever get. If you could solve this and through the correct approach, well done. If not, don't worry, just grasp the concepts. Please pause the video and solve this problem. Quantity A is simply -1. It is quantity B that we need to worry about. We know that x is negative. For x equal to a significant negative number such as -5, the value of quantity b becomes negative 0.2, which is greater than quantity a. However, when x is a small fractional negative number, such as, say, -0.1, the value of quantity b turns out to be 1 divided by negative 0.1, which is -10. In such a case, quantity a turns out to be greater. We got contradictory answers here. Therefore, D is the correct answer. Please pause the video and solve this problem. When x is a small positive value such as, say, 0.5, the value of mod x is 0.5, the value of x cube is 0.125. This inequality is honored and quantity a turns out to be greater. However, for a value of x such as -10, still this inequality is honored, but in such a case, quantity b is greater. We got contradictory answers. Therefore, D is the correct answer choice. Please pause the video and solve this problem. X squared less than 1 suggests that x must be between -1 and +1. And for this entire range, the second inequality very much holds. So we don't really need to worry about this second inequality here. Let's take different values of x in this range. So for x equals 0, quantity A and quantity B become equal. We get C as the correct answer choice. However, for a value such as x equals 0.5, quantity A becomes 0.5, whereas quantity B becomes 0.125. So quantity A turns out to be greater, and for a value such as x equals -0.5, quantity A is -0.5, quantity B is -0.125. Therefore, for this case, quantity B turns out to be greater. So we have been able to get contradictory answers, which means D is the correct answer choice. Solving inequations-based problems by plugging values. While solving problems on any concept or of any problem type, plugging in values should always be only a backup option because plugging values takes time and lacks conviction. When you reach an answer choice by plugging in values, you are rarely 100% sure. Plugging values in possibility-based inequations problems. Please look at this example. The question is, which of the following cannot be true? Therefore, we need to look at all these possibilities. For plugging values in such possibility-based problems, we must consider 4 broad ranges. This range above 1, the range below -1, the range between 0 and 1, and the range between -1 and 0. Therefore, if we are plugging in values, we must plug in a significant positive number such as 2 for this range. We must consider a significant negative number such as -2 for this range. We must consider a small positive fraction such as 0.5 to represent this range, and we must consider a small negative fraction such as -0.5 to represent this range. Only when you have plugged in values from each of the 4 ranges is when you can be confident about the results achieved. For example, in this question, before deducing that something cannot be true, we must ensure that we have considered all the 4 possibilities here. Plugging values in range-based inequations problems. Let's take an example here. This is an example of a range-based inequations problem, as we need to determine that which of the answer choices represent this interval or this range. Plugging in values should only be a backup option because it takes time and lacks conviction. However, if you really must, please use the following 2 rules for plugging in values. Rule 1 is that the border values of the correct ranges lead to equal values on left-hand side and right-hand side. we get 25 on the left-hand side, and on the right-hand side, we anyway have 25. Therefore, the values on left-hand side and right-hand side have become equal, so we cannot eliminate this answer choice as of now. However, when we put x as 35 in answer choice C, we get 40 on the left-hand side while we have 10 on the right-hand side. Since these two values have not become equal, answer choice C should be eliminated. Similarly, answer choice D should be eliminated, and answer choice E can also be eliminated. Two answer choices remain. Let's now try putting in minus 15, and unfortunately for us, both the remaining answer choices lead to equal values on left-hand side and right-hand side when x is minus 15. Therefore, no other answer choice can be eliminated using the first rule. Therefore, let's look at the second rule now. The second rule is that the values between the correct range satisfy the inequality. Therefore, if we select the value of x from anywhere in this range, the correct answer choice should hold. For example, x equals 0 very much lies in this range. Therefore, when we put x as 0, the inequation must hold. On putting x as 0, the first inequation becomes 10 is greater than 25, which is of course not correct, whereas the second inequation suggests that 10 is less than 25, which is of course correct. Therefore, answer choice A should be eliminated and B can be selected. B is the correct answer choice.